As Steve briefly explained in the weather section, the altimeter is an aneroid barometer which measures atmospheric pressure and gives an altitude indication in feet. Because atmospheric pressure is constantly changing, the altimeter indications will be correct only if the instrument has been set for the current atmospheric pressure. This is done by adjusting the barometric scale to the altimeter setting, which is the station or airport pressure reduced to sea level and given in inches of mercury. All altimeter settings are given on the basis of sea level pressure, providing a common reference for altitude separation of aircraft. The altimeter setting is the same as the barometric pressure only if you are at sea level. For airports at higher elevations, the altimeter setting is what a barometer would read if you could put it in the bottom of a pit dug down to sea level.
The altimeter setting is the baseline for the altimeter, or the sea level atmospheric pressure, where the altimeter should indicate an altitude of 0. If the altimeter setting is increased, the altitude indicated will also increase. Conversely, if the altimeter setting is lowered, the altimeter will show a lower altitude.
At lower altitudes, atmospheric pressure lapses or changes approximately 1 inch of mercury per 1,000 feet. Changing the altimeter setting 1 inch of mercury will change the indicated altitude about 1,000 feet. Remember that pressure decreases with altitude. If an altimeter senses lower pressure, it will indicate a higher altitude. Conversely, higher pressure indicates a lower altitude on the altimeter. Even though you will fly the airplane by the altimeter indication, as a pilot, you will deal with a number of different kinds of altitudes. Indicated altitude is read directly off the altimeter when it is set to the current altimeter setting. Indicated altitude is the approximate height above mean sea level, abbreviated MSL. Pressure altitude is read when the altimeter is set to 29.92. Pressure altitude is used to solve calculator problems of true airspeed and density altitude. Density altitude is pressure altitude corrected for non-standard temperature. When atmospheric conditions at sea level are standard, true, pressure, and density altitude are all the same. If the temperature is warmer than standard, density altitude will be higher than pressure altitude. Temperatures colder than standard will make the density altitude lower than pressure altitude. Density altitude is important to calculate because aircraft performance is related to density altitude. So density altitude must be known to calculate such things as takeoff, climb, and landing performance. Absolute altitude is the actual height above the terrain and is constantly changing unless the airplane is flying over water. True altitude is the true vertical distance above mean sea level. On aeronautical charts, the airport, terrain, and obstruction heights shown are true altitudes. True altitude computations are based on a standard temperature lapse rate of 2 degrees Celsius per 1,000 feet of altitude. Because of non-standard variations, the solution will only yield the approximate true altitude.
You can only be sure of true altitude when the airplane is on the airport surface or is flying in the mythical standard atmosphere. Unless there is an extreme variation from standard temperature, indicated altitude is reasonably close to true altitude.
The vertical speed indicator also works from the pitot-static system, measuring the rate of change in pressure and giving the pilot a readout in feet per minute, climb or descent. Just remember, there's a 6 to 9 second lag in the indications of this instrument. Also worthy of a mention is the alternate static source. If the exterior static source becomes blocked, the pedostatic system can be returned to operation by selecting the alternate static source. This vents the system into the cabin. Some instrument indications will be affected by this change, so talk to your instructor about your specific trainer.
After this brief look at the pedostatic system, you can see why checklist items involving the pedo tube, static source, and alternate source are important. Understanding its operation can help you deal with erroneous indications you may experience due to system or instrument malfunction. Like all airplane systems, the pedostatic system is very reliable and likely won't give you a moment's trouble during your flying career.